Geometric probability. Imagine this rectangle. We're on a computer screen and this white triangle has been carved out of it, and the computer is going to randomly select a point inside this rectangle. The question is, what is the probability that the point it selects will be in the shaded region? Because it could be this point in the shaded region. It might select this point, but it might select this point or this point or this point, which are not in the shaded region. So if a point is selected at random inside that rectangle, what are the chances it'll be in the shaded region? That's the question. Another way to think of it, as you'll see when we get to the answer, is you can think of it as what percent of this rectangle is shaded. So the first step is figure out the area of the shaded region. That is something you should all be able to do from the previous work we've done. So why don't you pause the video and quickly calculate, shouldn't take long, the area of that shaded region. So here's what it should look like. Remember, I want your work to be written this way. Area of a shaded is, start with the words, area of the rectangle minus area of the triangle. Replace the words with the formulas. So this is my rectangle formula. This is my equilateral triangle formula that we came up with ourselves, side squared root 3 over 4. We also could do half AP for an equilateral. We could do 1/2 base height, or we could do Heron's formula. And then show me what values you're substituting. The base of the rectangle is 12, the height is 5, the side of the triangle is 4. So I simplified, and it comes out to be 60 minus 4 root 3. That's the area that is shaded. In order to get the probability that is shaded, all we have to do is divide this answer by the area of the whole figure, which in this case is the rectangle, 60. But I don't want to do this. I don't want to take this answer and now out of nowhere just put a 60 underneath it, because that's no longer representing the area that's shaded. That's representing the probability. So every line needs to be equal to the line above it. So the reason I started you with this is I want you to see the only extra step we need to do now is we have to divide. I don't know if we can get all that or not. No? Okay. I'll do. Okay. How about that? Can we get all that in one shot? From here to here? Okay. So the difference is, to get the probability that's shaded, we do what we did before. We get the area that's shaded, but we also say we're going to divide it by the area of the whole figure. So every line is equal to the line above it. So just like over here, area shaded is rectangle minus triangle, rectangle minus triangle. I divide that by the area of the whole figure, which is the rectangle. So area of rectangle is base height minus the triangle, s squared root 3 over 4, all divided by the rectangle, which is base height. Then I put in my values, base times height for the rectangle, side of the equilateral triangle, squared times root 3 over 4, and I'm dividing by 12 times 5, the area of the rectangle. So the exact answer comes out to be this. And we're going to be rounding these off in the homework that I assign you to the nearest hundredths. So I'm going to show you in a moment how to put this in your calculator. We should get 0.88. But what I want you to see is, if you look just at my numerators, you'll see that it's exactly what we did before. This first line that we did before is my first numerator. The second line I did before is the numerator. The third line that I did before, when I put my values in, right here, is that numerator. And then I simplified to get 60 minus 4 root 3. That's the numerator. Every line here is the numerator if you're just finding the area of the shaded region. The denominator in every line is just the area of that whole rectangle, which was 60. The area of that rectangle, base times height, is 60. So this might seem overwhelming, but I want you to realize it's only one more step compared to everything we've been doing already. You're just dividing the area by the area of the whole figure. Now, calculators. I'm going to have some. I'm going to type in my answer, and I want to point out a couple things. If I do this, I'm going to get the wrong answer. 60 minus 4 root 3 divided by 60. That's not going to get me 0.88. The answer to a probability question will always be 0, 1, or in between. If you get less than 0 or more than 1, you made a mistake. The closer it is to 1, the more likely it is to happen. The closer it is to 0, the more unlikely it is to happen. The reason I didn't get the right answer is because the calculator thinks I'm asking for only 4 root 3 to be divided by 60. I need to indicate that this entire expression was my numerator. So I need an extra set of parentheses, 60 minus 4 root 3. Now every time you have an open parenthesis on a calculator, you need to have a closing parenthesis. You should have the same number of opens as closes. So I'm going to close my square root number. I'm going to close my numerator. So you see I've got 2 open parentheses and I've got 2 closing parentheses. And I want to say all of that is being divided by 60. And that's going to get 0.88. So when you're working on this on your calculator, if you're not getting an answer between 0 and 1, you made a mistake. You have to go back and either check your work on paper or check your calculator entry. So what we are saying there is if we think of this as a percent, move the decimal 2 to the right, multiply by 100, we're saying 88% of that rectangle is shaded if it were drawn to scale. All right, a couple more to look at. I'm going to go a little faster as we go. So you might just try this one on your own. Can you figure out if this is a square and a circle is inscribed, radius of 6, and a point is selected at random inside the square, what's the probability that point will be in the shaded region? All right. So first, if the question were, what's the area of the shaded region? It would just be the square minus the circle. Square is side squared minus circle pi r squared. The side of the square is 12, and I know that because if the radius is 6, the diameter is 12, and the diameter can be drawn in any direction. So if I were to draw the diameter this way, it would be 12, and that's the same length as the side of a square, right? If this is 12, that's the same length as the side of the square. So the side of the square is 12, the radius is 6, so 144 minus 36 pi is the area that's shaded. But if we want the probability, then on each of these lines, we have to divide by the area of the whole figure, in this case, the square. So here's what the work looks like. And again, you'll notice that the work I did above is the numerator on each line. The only different thing I'm doing now is I'm saying that I'm going to divide that area by the whole figure, which is a square. So my answer gets divided by 144. So the way that would look on a calculator, I'll type it in real quickly, is this. Notice again I put parentheses around my numerator because I want to say the entire numerator is being divided by 144 and I get 0.21. So about 21% of this square is shaded. Last one I did out, and then we'll just quickly look at a couple things in the book. I'm not going to do any calculations with them, but just to get you familiar. This is the hardest one for today. If the apothem of this equilateral triangle is 1 foot, and a point is selected at random inside that circle, maybe here, 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 what are the chances, what's the probability that it will be in the shaded region? Again, another way to think of it is what percent of that circle is shaded. So you can hit the pause button, give it a shot. All right, so if we were going to work on this, we'd have to know the radius of the circle, and we're given the apothem to be 1. So a few lessons ago, we learned about regular polygons, and when you draw a radius, it always bisects that angle. So if this is a 60, 60, 60 equilateral triangle, this would be 30 degrees, and if that's 90, that's 60. So I guess we got a special right triangle here. Short leg 1, hypotenuse 2, and the long leg is root 3. which means one side of the triangle would be root 3 plus root 3 to root 3. And that means the perimeter of the triangle is 2 root 3 plus 2 root 3 plus 2 root 3, 6 root 3. So just being given that one number, we can get everything we need. If we were doing the area of the shaded region, that would be circle minus triangle. So pi r squared minus half AP. And I just showed you the radius is 2, the given apothem is 1, the perimeter of the triangle was 6 root 3, so when you simplify each one, here's the area that is shaded. But the question was probability, so I need to divide every line here by the area of the whole figure, which was the circle. So what your work should have looked like is this. Now again, the numerators are what I just showed you. The numerator is how you get the area that is shaded, but now I asked you for probability of the shaded. So every line is divided by the area of the whole figure, pi r squared with a radius of 2. So the answer is the area that I just showed you divided by the whole circle, which is 4 pi. Now, a couple things here. If anybody's wondering, don't these 4 pi's cancel? No. They would cancel if this was multiplication up here, but when you're adding two terms and dividing by one of them, they do not cancel. So that's that. There's also a calculator issue, an extra hard calculator issue on this one. If you put it in your calculator correctly, you should get 0.59. You might want to check that on your calculator. I bet you most of you are not going to get that. There's something extra tricky here. Let's look at this. If I offered you $100 for an approximation of 10 divided by 3 pi, and I said no calculator, no pencil, no paper, in your head to the nearest whole number, just an integer, what is this closest to? Is this approximately 9? Is this approximately 3? Is it approximately 22? What is this? Well, we know pi is a little bit more than 3, so that denominator is 3 times a little bit more than 3. So that denominator is a little bit more than 9. So this is about 10 divided by 9. So nearest whole number, that would be 1. If you put that in your calculator, now we expect it to say 1. 10 divided by 3 pi, I'm not getting 1. But we just reasoned out that it should be 1. So what's going on here? Well, what's going on here is a parenthesis issue. The calculator thinks I'm asking for this. 10 divided by 3 times pi. That's what it thinks I'm asking for. It doesn't know that that pi is in the denominator. So it's just following the order of operations. It's doing multiplication and division in order from left to right, and it gets that answer. I have to type it in correctly if I want the right answer. And correctly would be this. Telling it all of that 3 pi is in the denominator, and then we get a little bit more than 1. So that's what's going on with this answer. You don't want to go through all this work and not know how to type it in. So here is the correct way. I'm just going to type it, then I'll hold it up to the camera in a second. Here is the correct way to type in what you see on the paper there. Divided by 4 pi. All right. So look at all those parentheses. Parentheses here to say that the 4 and the pi as a group are in the denominator. This parenthesis and this parenthesis are to represent where my numerator begins and ends. This parenthesis and this parenthesis are to represent where the square root value begins and ends. Notice I've got 3 sets of open parentheses and 3 sets of closing parentheses. They should always match. And notice I got an answer between 0 and 1. If I didn't, I'd know I was wrong. So the answer is 0.59. 59% of that circle is shaded. So you probably have to watch this video more than once. Not going to do any calculations here, just one final wrap up. If I were to ask, so this is an old homework assignment, but if I were to ask you to go back and find the probability that a point selected at random is in the shaded region, you should be able to do these because you know how to get the area that is shaded, in this case rectangle minus circle. The only extra step now is you would divide that by area of that rectangle. Here, circle with an inscribed hexagon. If I said what's the probability for the shaded region, the answer would be, first get the area that is shaded, circle minus hexagon, and then whatever that area is, you divide by the whole circle. So it's just one extra step of dividing by the whole figure. So your homework's going to be coming from these pages. A couple of hints for you. Number one, wants the probability that a point selected at random in here is going to be in the shaded region. So just figure out the number of square units, the area that is shaded, count them up, out of the area of the whole square. This is going to be, let's see, circle minus square would be the area, and then you divide it by the area of the whole circle. Last thing I'll say is if you look at these spinners, if I want the area that is shaded, this is a sector of a circle, and we learned how to do sectors of circles. You get the degrees, in this case 72 degrees, put it over 360, multiply that fraction by the area of the whole circle. So a fraction of the whole circle is the area that is shaded. And then if you want to get the probability that the spinner lands in that, you can just divide that answer by the area of the whole circle. So these are going to be challenging. You'll have to go slow, watch the video again, and I'll see you in the office hours. Good luck.